Welcome back, everyone. So now we will start more into the BIM corner, Digital Twins, and our first guest is Brendan. So welcome, Brendan.
Hi guys,
Super nice to see you here.
nice to meet you, Stijn.
Some time ago, I was invited by Brendan to his podcast, and we had a good chat about automation. And at the end of the podcast, we were chatting a bit about what Brendan was doing. And I said to him, Brendan, you should be also invited to a podcast and tell your story because you have a great story to tell, not? So Brendan is a structural engineer. He was working at VSP in Australia, and he was basically rescuing all kind of buildings that were about to fall apart. And he was traveling all around the world doing this. So he's a very, very, very experienced structural engineer. And he also has a YouTube channel that he has online where he shares all his insights, which is super interesting. And today, Brendan, you're part of course of Zuru.
Yes.
Yeah, and we're really looking forward to your presentation. And for those people that are just joining us, there is a channel where you can ask questions. And at the end of the presentation, we will reply to those questions. So, Brendan, the floor is all yours. Brendan, we are not hearing you at the moment. I think you're muted.
Is that better? Can you hear me now?
Yes.
Yes, it's working now.
Great.
Hey guys. So I was just mentioning that I'm going to go a little bit into some of the stuff about how you can actually utilize BIM and digital engineering into your workflows, but also a little bit about what we're doing at Zuru because it's really quite exciting. We're really looking to revolutionize the way we actually work. Now, with digital engineering, it's really going to be the future of engineering. It's the where we're going, and it's really adapt or die. So really, it's something that we have to adopt, and we're probably talking a little bit of the converted here. You know, it is a digital conference, but it's really something that we need to take and actually take seriously within all areas of engineering. If we don't, we'll get left behind. And probably one of the biggest things that we find with the industry is we are the biggest problem in engineers. Like we have copy and paste errors and other problems with our workflows, and this is why the digital engineering space is where we need to try and be pushing the boundaries and really helping make our designs more efficient, but also more safe. But when I also say that we're also the problem, typically when we develop something, we're developing it in the potentially the wrong way. We typically start off with something like Excel, then move into something more complex, and then we run into the limitations of such a program. And this is where you want to try and probably move into the right tools to more start off with. So a really easy way to do that is a program called CodeLabs, which allows you to both build an interface, but also have the power of Python scripting behind you, which I've got off to the right hand side. But those can't go past the sponsors of this conference, which is VIKTOR, because their program also allows you, especially if you're in the corporate space, to have both the control and also have the power of the programming behind you and actually them having their own fingertips. So this is really what the benefit of something a program like VIKTOR has, because it has that benefit. It also means that you can also make sure that you're on the latest versions, which is another big problem of the Excel that you typically have. But when you're looking at your workflows, you got to make sure that you're linking them end to end. Typically, when we're looking at digital engineering, we're just looking at linking the modeling space to the analysis. We don't actually link it back to the BIM. So when we're looking at how we build our workflows, you want to build it end to end. So you're starting off with your digital model, importing it into your analysis software, then moving into more the design space, then porting it back. So you get this loop end to end. One of the best examples I've had in the past was we had a big time where where we were going backwards and forwards with a design with a client, and they went through and went, "Oh, we want to change the load," and this was really at last minute, and we had like over about 1,000 columns on this project, so they went from one load and almost doubled the load on the project. So there would have been a significant undertaking to change all the column loading and all the design that we had in our building. But because we had linked the workflow, we were able to re-import the new loading that we had, redesign all those columns to the most efficient way that we could, and then upload it. So within a couple of hours, we had the new loadings, the new column sizes, we were able to issue that to the client. So the client was really impressed with the work we did, and we were able to snatch what could have been potentially weeks worth of work in just a couple of hours. So even though it takes a little bit of more time at the start, making sure you're building your workflows from end to end is really beneficial, and it will save you time and make things a lot more efficient. But also, when you're looking at your workflows as well, you shouldn't overlook the leveraging AI. And even you can do this quite easily with a lot of tool sets that you actually have in Grasshopper. Now, a lot of us probably use Grasshopper in our digital workflows, but there's a number of plugins here that allow us to actually leverage the power of AI into our designs to make it more efficient. Now, about 6 years ago, I was doing this sometimes with efficient design for steel structures using Octopus. Now, it's come a long way since then. There's actually a lot more benefits, but even then, you're able to have this matrix and achieve the most efficient structures in the right way, making decisions through using neural networks and other aspects like that in your workflows. So even now, it's getting even better. So it's something that you should really look at as well. But something you probably shouldn't go past is looking at large language learning models. Now, you may be thinking when you've used them in the past, they don't produce that good a result because they're just scraping the whole internet across everything, across every data. You don't know whether the data is correct, and most of the time it's not, especially when you're looking at the answers. Now, probably the biggest thing is how you've actually put that prompt in. Now, this is based on a crowdsourced prompt by NASA, where they're able to break it down and get a lot better results out of the prompts that you're getting. Now, it's broken down into a couple of different ways. So you've got the blue areas, which are really refining who you are. You're saying you're a world-renowned structural engineer. So then it knows what context to put the information in. Saying that you're a leading expert in seismic engineering, time-dependent behavior of concrete structures, structural engineering, mechanical engineering, and the environmental science. Then in the next part where it's going into red, it's sort of saying how to bound that information that it's sending through to you. So you want to make sure that you're trying to push the boundaries of structural engineering in a codified way, but also allow for complete architectural freedom. So not just being too conservative. Then the yellow part is really, really important, where it's saying that it must be cited peer review sources for all the information that it gives you. So you can see off to the side, it's actually given me advice and also given me citations to each of those areas. Now that is really important. Now, because you want to make sure it's getting it from the correct space. There was a lawyer in the US that actually used a large language learning model to help with his case defense. But when he had actually cited some of the cases that it came up with, they were fictitious. So he actually got disbarred for this. So we need to make sure that we're always double checking the information that it's providing. Now, the green section is really only the prompt where it's what I've actually asked for the advice that it's given to me. But by prefacing it with the advice before it, it's able to give me a lot better advice in such a system. Then we can keep going. We can ask another system, and where it goes through some of the devices that I could potentially use in a seismic design, especially if I'm trying to push the boundaries of engineering. Now, of course, we all know what a base isolation system is. It's quite commonly used in a lot of high-end structures, but also goes into a number of different ways, such as energy dissipation devices, and also performance-based design. Now, it doesn't give you the details, but you can drill down on it and ask questions about these things. Even if you're trying to do some literature review about how something actually works, you can actually ask it to help you with that literature review and finding different papers and articles on those different topics that you're trying to follow. But let's move into about how we're trying to push the boundaries of BIM. When we actually look at where BIM currently is, it's really a complicated system. It takes ages to learn. It's like learning a new language. You're trying to look at how everything is appearing and how it goes together. You need to learn to get better at it. And good modeling, even when you're first starting out or whether you've had a lot of experience, takes a lot of time. Now, it's worth setting up the time to get those models, but the current versions of BIM software means that you have to put a lot of effort in to get a model that's actually going to be really effective. And of course, because it is complicated, we're saying it's got that learning barrier, so it takes time to learn effectively for it to be used in an effective manner. But also, a lot of time you have separate models, and I'll talk about that a little bit later. So typically, you need a group of experts to come together to be able to provide designs for your buildings. So there's really a barrier to accessibility in these type of softwares and allowing it to be used properly. Because when we look at the different groups that actually use BIM in the construction industry, you have architects, engineers, and then builders. Now, when they're looking at the architecture, yes, they're quite good at visual design and showing off how the buildings actually look. They collaborate, well, sort of. There's still a lot of manual processes typically in the collaboration, and they do a lot of code compliance. Engineering, we still use it to produce the drawings as well, but typically we'll have separate models for analysis, we'll have separate models for mechanical models, electrical models, hydraulic models. It's not typically in the same space. So we're using all this additional work. And then in the construction industry, you typically can use it for planning, but then you'll have typically shop drawings, reinforcement drawings, but most of the time it's still paper. They haven't really moved up into the digital space and utilizing a lot of the models that we have. But the biggest problem is none of these are linked. So potentially you could have errors because the structural engineer hasn't updated from the architecture. The architect hasn't certain something correctly, or the mechanical engineer or someone else is working off different models. So we're all working in the digital space, working this large BIM area, but not working off the same system. So what we want to do is, well, when we're looking at workflows, is trying to see if we can link them. So we're going between the architect and engineer and back and forth. Now, there is problems with doing stuff like this, is potentially you're going, if an engineer moves a column, who's responsible? So it's very hard to work in the same space. There is people trying to work out how to do this, but it takes a lot of control. But even with the limitations, you can set up design workflows that allow you to share information effectively and see where the differences are in a lot of these softwares. It just takes a little bit of time at the start of the project to set it up with the architect that you're working with. Now, what are we trying to do at Zuru? Well, we're originally looking at what is currently happening in the digital space and where the BIM, you need a lot of these qualified users. Our current goal is to create a user-friendly BIM software with machine learning features, and in the future, eventually even potentially make it architect-free through using AI-generated BIM architecture and allowing clients to have access to the whole system from end to end. So it's end-to-end automation. So this is just a quick showing about how we actually try to do this. So we're writing our own software at the moment that will allow us to control the design and design it from end to end. We're also able to provide them with a cost and a fixed cost at the time of purchasing. We will then have factories that will help produce those buildings. Now it will be somewhat modular, but it's a modular to the next level. So we're breaking it down to each component, so it really has no limit, and help with the assembly of those construction. So we really got complete integration from end to end. So we allow from design to production to delivery. So really looking at how we change the way we build and bringing BIM into the next level through both machine learning and AI. So we start off with the design with our own software. We then walk them through the purchasing, and then they can look at different things and change the design as we go and giving them advice on how they can potentially make things a little bit cheaper. We will then be able to lead into the production of that building. We'll then lead it to shipping and then give them directions on people that they can go to help assemble the structure. Within a month or so, we can actually build a whole building from start to finish. So what our goal is that everyone should be able to create their own dream home in a snap, no sweat, with you're just in control through utilizing some of the best engineering capabilities that we have available to us and using some of the best machine learning, both in engineering and architecture. And you may be thinking, like, how can we actually do this? And I've got some videos here of what we were actually producing over a year ago. This is older content, but you can see through here, you've got quite a lot of rendered space. You can't see a lot of the engineering behind it because the engineering has been completely automated from behind. So it allows you to not have to worry about the engineering. It will actually give you the feedback and advice if things aren't actually working. But you can see it gives a lot of power to the user that's using it and about how things actually look and how it's going to appear even in the day and the night. But we've got stuff that's improving more and more, and the videos getting even realistic renders, so you can actually see what your building looks like. Now, that was just a quick introduction about what we're doing, but if you do want to know a little bit more, you can probably reach out to me, as Anand was saying that I've got my own YouTube channel, but also you can reach out to me at my Zuru contact is Brendan.Hasty at Zuru. And so I think we'll try and go to some Q&A now.
Yes. Well, thanks a lot, Brendan. That
Yes.
sounds really futuristic, I think, and it's really nice to see that you are actually already doing this kind of stuff. I'm
Yes.
very impressed by it. So, could you maybe give a little bit more insight? So I was wondering, sort of in the let's say the technical side behind it.
Yes.
So, for example, the renders that you showed, do you use some kind of what kind of AI-based systems do you use for that?
So we're writing our own AI backend to help with the renders. The actual videos and pictures that you're seeing there were mock-ups from other people at the moment that using Unreal Engine. So we're building software from the back end, re-looking at how people potentially do it, make it a bit more gamification and make it a bit more easier for you to use, because a lot of software is quite hard to look at how it's put together. So there's a lot of focus on the UI and making it easy and rethinking about how you actually do it. So the images that you saw there are the older version of Unreal Engine. We actually upgraded to the new version. And if you have a look at some of the stuff that's coming out of the new version, it's basically almost realistic renders. So what you see is basically what you get through the correct lighting and stuff. You can also get scans of the area around you and get what the other structures around you. So you'll be able to put your building into real world space.
Yeah.
So that's what we're doing from the renders point of view. From the design, we're also using machine learning to help the engineer come from end to end and be able to produce a full engineering package for that building using performance-based designs, both the lateral designs and also for the gravity designs as well.
Okay, cool.
I think that fits very well with the question of the public, and it says basically this software calculates everything for you. So who's responsible for the design of who's liable for it?
So at the moment, we'll probably be looking at giving the access. Well, the access will be given to the engineers because obviously, with the way the current sector is working, you will need an engineer to hand it off, and we'll provide them with the full computation package and everything for them to be able to analyze that. They'll be able to look at the building. They've got the analysis software in the back end. They can spin it around. They can do it like you would with a CSI or an ETABS or Bentley. So we're giving them the power to be able to do with the full analysis. They'll be able to see what the results are. So they're able to make their own judgment and make their own call on it. In the end, it's really, if things change, would be potentially that maybe you don't need an engineer at all, but that's probably not going to happen for a really long time. You still need the engineer there, so we want to bring them along and want people to actually then double check things. Like with any software, you want to make sure that there is a double check at some point, so someone will need to go back and double check the results. But we're giving them the power of the analysis software as well by giving them access to that, like you would with any digital analysis software.
Nice. And the next question is, how does EFC, which is like the industry standard, fits in this whole story? And how do you transfer data with Revit, Grasshopper, or other programs your clients can use?
Yeah. So we will have access backwards and forwards. So we're building Grasshopper links and stuff and other ways to transfer that data between those other EFC softwares. We'll also be producing our own drawing set as well, because obviously we'll need to export a certain drawing set. At the start, it won't be a complete drawing set, especially for architecture, but for engineering, it should be a complete set. So some people may need to add some additional information in there, but we'll be able to give them access to all the primary software. So you'll be able to get it exported to the software that you're using, and then add your title blocks or whatever else, but it'll have most of the documentation there for you. Because obviously there's not a lot of changes because we're controlling most of the aspects of everything, and you do it all within the software. So whether you're putting your services in or or what else. The other one that I don't think I mentioned as well, it also does all the routing for all your services within your building. So you just have control of putting the lights, but it does all the routing and everything for your pipes within your structure as well.
Hmm. Oh.
It's very cool. And we're all very impressed, of course, with what you have shown. And Martin Day has a question for you. And it's basically, are you open to offer the software for other applications? Or is it only limited to the houses you sell?
At the moment, it's probably only really looking at limited to the houses that we sell, but you will have access to the whole backend software. So if you can fit within your design there, obviously we're doing our own design of our structures because we're offering it to everyone. So there'll be a little bit of access there, and you better see the analysis results, but primarily it will be from our buildings.
Cool.
And are you able to, so the houses you make, are they using different kind of materials, like the structural part of it?
So the structural part it will be primarily a steel structure. So it'll be primarily a concrete structure. So we have a concrete structure that will be of given depth, and it'll be able to allow you to have the services zones and everything within there. It also provides the formwork system there. So essentially, it's just like a plug and play system that you go together. The external walls will be like an AAC structural wall, so it provides the additional thermal characteristics as well. So we'll be able to provide some of the best detailing because we've got control of it. We'll be able to have really good thermal detailing from inside and outside, controlling each detail, as opposed to where a lot of those junctions are normally done by just add-on parts. So you're getting different companies to put it together. Because we control everything, we're able to really control all the fine details and really make really good connections through everywhere.
And this is also something the public is asking. So Michiel is asking, how many houses have you built until now?
So we've currently built 2 houses as a prototype, but the first 2 came together really quickly, and we'll get actually faster and faster and faster. At the moment, we obviously have to set up production lines and stuff to get it going. We're also testing a lot of structures, so we've done a lot of structural testing on all the systems. So all the systems that we're using have been thoroughly tested, and we will be releasing a lot of probably peer-reviewed papers as well to show the benefits and how actually we've pushed stuff to the boundaries. So using full-scale shake table tests for our structures as well, and putting for the full performance design through the solutions. So we're actually going to build our first couple of houses were 2 stories, and we built them in about a month or so, and that was slow. So we should be able to get faster and faster and faster moving forward.
Yeah, because you told me that you're investing in a factory, not at the moment?
Yes, we're building in the factory at the moment, but it's slow going to make sure they're designed properly because you don't actually know where your end goal is, especially when you're developing the product at the same time. So it's definitely going. When I say slow, it's only we're talking about months, not that long. But the factory takes time to put together to design correctly, especially if you want to do it properly. The time there's a lot of investment that needs to go in there to make sure you're automating and putting it together in the correct way to get all the savings.
And Martin Day has another question for you. So he says that there are some factories that have gone burst. So what do you think it's like making Zuru really unique, and what will be kind of the key of the success of Zuru?
So probably the key of success at Zuru, I think, is the fact that we're innovating across basically all sectors. So we have to have the software along with the factory, along with the design, and bringing a lot of people together. So we're bringing both structural engineers, mechanical engineers, and all them in one group to try and create an innovation. Without innovating across all 3 areas, you don't really have the ability to push the boundaries as far as you do. Because if you don't do that, you only got one part, you get limited and stuck in one area. So we've had to push the boundaries across all 3 areas at the same time. So this is really where our advantage gets there, and we're really trying to push the boundaries. And if we manage to do it, we should be able to change the way we build, hopefully forever, and actually bring us into the digital space and push the construction industry, which hasn't really changed in a really long time.
So one question is I have related to this, Brendan, is of this whole part of completely A to Z, what is the most challenging part of that whole process of getting there?
It depends on what on what you're working at, like, and it changes on time to time. Like the initial start was how did we actually come up with the how things go together, but it's funny, like you get all this effort on one area and then you get stuck for a while. For example, like how do we put the slabs together? But then once you get to a design that actually works, things just get easier and easier and easier.
Hmm.
So you sort of get to this monster, what I call like a monster design, product design, and
Yeah.
then very easily you go from this monster to something that is very simple. Like you go, oh, why didn't we think of that from the start? But then as we move on, then you think, okay, well now we've sort of solved this part. Then you go, then how do you get it into the analysis? Then it takes time about how you do the analysis, and the same thing sort of happens. You go from something really complicated, then you create a really simple workflow, and through that complete integration, it really makes it really exciting. So it's a bit of a, you sort of go up a hill, you get to something really complicated, then you go to something
Yeah.
quickly simple very quickly.
Yeah, that's often quite challenging, I think. So making something
Yes.
simple, that's of course quite a big challenge. So really cool to hear
But
that.
but I think that's also like the goal with a lot of these things is,
Yeah,
like, especially as engineers, we typically try and overcomplicate things, and it normally is to our detriment. Where if you try and think about it a little bit more and try and think about who your end users are, and the simplicity is really where you want to go. So it's really about trying to delete stuff. Typically, we just add and add and add. Where what
Yeah.
we should be doing is trying to cut until it doesn't work.
Yeah.
And then that's the point
Yeah.
of where you need to add back in.
Yeah, I know, for example, I don't know if you have been inspired by that as well, but that's also, I think, at, for example, companies like SpaceX and Tesla, that's very much in their DNA as well. How can we remove parts? And it's very easy indeed to add more stuff, but be really critical on that. Yeah.
Yes, it's very similar as well. And one of the things
Yeah.
that like we've also got is very much like not a sunk cost fallacy, right? So if we ever find something that's better, and even if we
Yeah.
spend 6 months on something else, it would just change it because it is the better direction. Don't try and do it because that's how we've always done it before. And that's probably one of the biggest things as well, because we're bringing together multiple people, especially engineers and mechanical engineers, trying to think about how we actually build something differently as well. So we're trying to revolutionize across every area. So
How big is your team?
our team, we've got, it's in the hundreds across multiple countries. So we've got divisions in New Zealand, LA, China, India, Italy. So we've got big teams across different areas that are doing a lot of work, and try to find the best people across the globe, really, to help and really revolutionize the way we build.
Yeah, it's super nice to hear. And you clearly have been growing quite fast.
Yes.
Do you see this impacting the speed in which you can change designs and take decisions, like in the flexibility you have?
Not really. Because we have a very flat structure, and we sort of, you get experts together to do their best work. It hasn't really slowed us down at this point, just through the way the structure of this company works is not really like anyone can reach out to anyone. Like you got a lot of big companies, it's very hard for like the junior guys to reach out to the directors of the company, but there's a lot of free flow of communication. So not having that, a lot of what you'd call like middle type management, it doesn't really exist in there, because that's where you really get bogged down. So I'm having the people that are doing it, the people that are making the decisions as well. So it doesn't slow us down as like a lot of companies, because we're looking at it a different way.
Maybe going back to the technique. So Pavel is asking, besides visualization, where else do you use AI?
So using AI both in the visualization and trying to look at how the architecture goes together, we're using AI in the structural design to make sure it's the most efficient way. So saying where do you put beams, how much reinforcement you need to have in it, like designing the columns and all that. We also will be using AI into eventually into how the placement of services and stuff in your structure, how you light up the structure, how you do the ventilation, and every aspect will be using some sort of machine learning in there to help making sure that you're getting the most efficient design across your whole house.
Wow, yeah, we're really looking forward to see where Zuru is in 5 years. Like now,
Yes,
it will be amazing for sure.
be amazing.
The last question is, what time is it there in Australia?
Australia, it is, was it 3 a.m., I think?
Yeah, so it's super nice to have you here, and that you're here at 3 a.m. really shows you have a passion for this, and we appreciate this enormously. So thanks for being
Thanks for having
here,
me.
Brendan.
No, it was a
Thanks
good
a lot.
session, and hopefully inspired a lot of people, and hopefully we push AI into the next generation and building industry.
We will,
Cool.
for sure.
I'm sure. Hey, have a good night's sleep, hopefully, Brendan. Thanks a lot.
Thank you.
Bye-bye.
See you. Bye-bye.